Welcome everyone. The question that is shown on the screen, it is a CBSE 2026 physics paper question. A square loop of side 50 cm is placed in an uniform magnetic field of 3 Tesla acting perpendicular to the plane of the loop. So let us consider that this is the square loop and this square loop is placed in a magnetic field which is perpendicular to the plane of the loop. So like this. So this is the direction of the magnetic field. Okay, and if you say that if capital A is the area of the loop, okay, if capital is area of the loop, so area vector is also perpendicular to that of the plane of the loop. Okay, so B vector and A vector are in the same direction. So if we want to find it out what is the magnetic flux through it, then we can say phi 1 equal to B into A multiplied by cos 0 degree, because the magnetic flux is BA cos theta. There is no angle between the magnetic field vector and area vector, so it is BA cos 0 degree, so it becomes simply BA. Okay, if the loop is rotated through an angle 90 degree, that means whatever be the direction, the loop is rotated through a 90 degree. So I can say now this is the position of the loop. Okay, magnetic field is in the same direction, magnetic field is in the same direction, but since the loop has rotated by angle 90 degree, so we can say this is now the direction of the area vector. So this is the angle between the B vector and the area vector, and that is 90 degree. Okay, and that is 90 degree. So if you want to find it out what is the magnetic flux through this square loop, that is B A, and the angle between the B vector and the area vector is 90 degree. So cos 90 degree is 0. So this will become B A multiplied by 0, so it is 0. Find the value of the EMF induced, it would be. Obviously 4 options are given, and for that purpose we need to take the help of the electromagnetic law of induction, and it basically says that E equal to minus of del phi divided by del t. Okay, so we can say del phi is nothing but phi 2 minus of phi 1 divided by t2 minus of t1. That is the change in magnetic flux divided by the change in time. So phi 2 is 0. Okay, phi 1 is BA. Okay, t2 minus t1, initially the time is 0, and the time taken in doing this, it is 0.3 second. So t2 is 0.3 second. Okay, 0.3 second. And magnetic field, obviously this is our 3 Tesla, and this is our nothing but the magnetic field, and the square loop have the area of side is 50 centimeters. So area we need to calculate. So it is 50 centimeter, 50 divided by 100 whole square, and that is in meter square. Okay, so let us put the values, and I think you will easily understood that it is BA minus minus becomes plus. This is 0.3, that is the time. So what is B? B is 3.0, that is simply 3, and it is 50 divided by 100 whole square, that is the area, divided by 0.3. So simple just calculation, some calculation slips only. So it is 3 and it is 0.3, so I can say it is 3 divided by 0.3. Okay, and 50 by 100, that is 1 by 2. So it is nothing but 1 by 2 whole square. So if I just take this decimal point, if I put it here, so this will become 30 by 3. So this will cancel out and it gives you 10, and it is 10 multiplied by 1 by 2 square is 1 by 4. Okay, what is 1 by 4? 0.25. Okay, so it is 0.25. So it is 10 multiplied by 1 by 2 square, that is 0.25. Okay, so it comes 2.5 volt. Okay, 2.5 volt. So we have to check anywhere we have done the mistake or not. The side is 50 centimeter, we have taken, we have converted into meter. 50 divided by 100 square, so area I have calculated perfectly. The magnetic field B is 3 Tesla, so it is also calculated perfectly. The time is 0.3 second, that is also taken correctly. So B is 3.0, I have put correctly, 50 by 100, and it is 0.3. So 330 divided by 0.3, so it becomes basically 3 by 0.3 becomes 30 by 3, so it becomes simply 10. And 150 by 100 is 1 by 2, so 1 by 2 square is 1 by 4. 1 by 4 is 0.25. 1 by 2 square is 0.25, so it is 2.5 volt. So little bit decimal point is not matching, but the answer is 2.5 volt. So the if it is 2.5 volt, then the option A we can put, mark it, it is the correct answer. Thank you all of you.